Hey everyone, today we're looking at the paper Pitfalls of Static Language Modeling by authors from DeepMind in London, UK. The paper deals with the problem of time degradation of language models. So basically the authors study what happens if you train the model on a training data from a fixed time frame, such as all news articles from the 60s up to 2018. And then what happens if you test then on the news articles from the years 2019 till 2020? Is the language model able to perform just as well on those last 2 years? Or is it having problems in terms of because it's not aware of the new trends, new names, new concepts coming up in those last years? So is it able to preserve the performance, or is it breaking down? And how often is it breaking down? How often is the how far ahead in the future would the language model still be working? So this is an interesting problem in general, which is going to happen basically if you have a language model or any model in machine learning. How far ahead into the future can you use it with guarantees that it will still work pretty well? And when will the model start breaking? And then you would have to retrain the model from scratch using the new training data that has come out. Or would you also be able to just fine-tune the model with the new news articles that came out? So those are the type of questions that the authors discuss in this paper. Kind of the main points is, how robust are those large-scale language models such as the Transformer XL when tested on future training data? Are they, do you get any benefit of having a bigger language model for being able to deal with future training data better or not? Also, how can you most efficiently fine-tune these language models on the new released quote-unquote news articles? And how can you do this without having to retrain, let's say, every couple of months? Because this will be very computationally expensive, and you might also never know, like it could be that some new event comes out which changes everything. For example, we've had some quite interesting, or not interesting, but quite a big change in the world in the last one calendar year or so, from March last year up to now. So would a language model trained up to March 2020 be able to perform just as well on news articles after March 2020 when you had these big changes in the world? This is a valid point, and it's a valid question you have to think about if you are using those language models in production. So to kind of give you the main findings of this paper, what the authors do is they compose 3 datasets, and they always kind of hide all the articles up to 2018 up to 2020, and they are focusing on 3 domains or 2 domains. You have archive scientific papers, WMT news articles, and another dataset of news articles, which they call custom news. They train the Transformer XL language model up to 2018, and then they test using news articles and scientific papers from different months from that 2-year period. And basically, what they find is that there's a big impact in terms of perplexity on the y-axis here. So if you start off in the beginning of 2018, where still the language model is up to date, you're getting a much lower perplexity versus the articles published at the end of 2019. And this is particularly strong for news articles, but it's still you can still observe it for scientific papers. What the authors find is that the impact is particularly observed in terms of proper nouns and numbers and nouns. If you take a look at the part of speech tags, the perplexity divided in terms of part of speech tags on those future news articles. So the proper nouns are particularly impacted as new proper nouns are becoming more prevalently used in the future news articles. If we take a look at the topics of the news articles, sports and politics seem to be the most affected with time because those are rapidly changing. And in sports, you always have new teams, new players becoming stars. And in politics, you have a lot of shifts and changes for sure, as well as new events are taking place. But also in the other topics, you still have an impact and degradation with time. One interesting finding furthermore is that if you take a larger language model, let's say if you compare language model with 450 million parameters and a language model with 300 million parameters, you are observing similar pattern in terms of degradation of perplexity of those models. So you're getting a increase in perplexity as you test with news articles further away in time from your training data. So it seems that having a bigger language model is not having a major impact in terms of reducing this time degradation. So you still need to update that language model. And finally, the authors also discuss some techniques for dealing with this time degradation by fine-tuning the language models on the new, basically the test data that it's already covered. So basically continuously updating these language models. Let's say if you take a look month by month, let's say you're testing on January of 2018, and then you fine tune on that month. And then for February of 2018, you're using the model fine tune also on the previous month, and then the previous month, and then the previous month, and so on. And this seems to be effective at alleviating this time degradation, but it's a very interesting research topic of how to come up with language models that are going to be more robust in general, even without any fine tuning. Is this possible at all? It's an interesting question because obviously, the models are going to be updated with time, and even if some models are more robust, at the end of the day, maybe there's not a lot you can do about it. But maybe there are some strategies with which the models are more general and thus are, even though there's new trends, new names, new proper nouns in upcoming news articles, still they are capable of dealing those. Maybe on the fly, they're able to understand, okay, there have been some new things happening, so they're able to still perform robustly on even on those new trends and new things that came out since the model, the training data of the model came out. So it's an interesting paper, and I wish there was some, they discuss how this could be done, but they leave it for future work regarding how to come up with such more robust models. And I'm sure this will become a topic that is more and more relevant in the future as you're getting bigger language models and we don't have a lot of computational power, or it's a big hassle to retrain them. We need good strategies to fine-tune those and good strategies to come up, we need to come up with more robust models. So that is all that I wanted to cover for today. Please like and subscribe, and I will talk to you in the next video.